In this problem, we'll find the simplified form of the difference quotient for the function given. So we have a form for our difference quotient, which is just a rate of change in this function with respect to x, where the change in x is defined as that variable h. So you can think of this as slope. But again, it's the slope, or the amount of change in the function as x changes by whatever h is. So to get this done, we've got our function, and everywhere we see x in our function, we're going to plug in x plus h in order to get this first term here, f of x plus h. So instead of 5x squared, I have 5x plus h squared minus, instead of x plus h. So there's our first term, or we should say our first term of our difference quotient. It's made up of two terms here. And then we'll subtract f of x. So f of x is just the function, and the function is two terms, so we'll put it in parentheses since we're subtracting. We've got 5x squared minus x. So here we have, this piece is f of x plus h minus, here's f of x. And this whole thing is over the denominator h. So next up, we're going to expand. We're going to take care of any distribution we have to do, look to combine like terms, and then ideally we'll be able to find a common factor h that we can cancel out with that h down below. So we'll start by expanding this binomial x plus h. We've got to square it. So we've got x plus h times x plus h. There's a 5 in front. If you square a binomial, you can square the first term, so that's x squared. You can multiply the two terms together and double, so that would be x times h doubled is 2xh. And then squaring our last term is just the h squared. Another thing you could do here is you could FOIL if you're familiar with that process. You write x plus h times another x plus h, and then you could FOIL that out. So that's our first term. We can, of course, distribute the 5. I guess I'll proceed with this. This negative sign needs to be multiplied in to this binomial. So we got minus x and then minus h. And then we've also got over here, this negative sign needs to be distributed into this binomial. So it's going to give us minus 5x squared, and then that double negative gives us positive x. And this whole thing is still over h. So what will happen with the majority of these is you'll get a lot of things that will cancel. And then since we're looking to cancel out that factor of h down below, ideally all that'll be left over once we combine like terms is terms that contain a factor of h in them. So if we look here at our numerator, if I were to distribute this 5 in, I'd have 5x squared, and I've got a negative 5x squared over here. Right? If I distribute the 5 in, it's going to leave behind, I guess I'll keep this in black. 5 times 2 is 10. So we've got 10xh. The 5 distributing to the last term here, that's h squared, gives us 5h squared. And then we've also got a negative x and a positive x that are going to cancel, which leaves just this minus h as our last term up top. So if you notice, we have 3 terms in the numerator's place, all of which contain h. So the last step would be to cancel out that common factor. Right? We could show that by, if we wanted to, pulling out that common factor of h. That will leave behind 10x plus 5h minus 1. And then now that we have a factor of h above and below here, we can cancel that out. And that gives us our simplified form of the difference quotient. So this here would be the answer to part A. Just this, 10x plus 5h minus 1. Now to fill out the table, which is part B, you could plug in 3, plug in 2. 3 would go in for x, and then 2 in for h, and then you could simplify the expression for all 4 of these rows here. A very simple way to do this is, if you notice, since x is 3 the whole way through, let's just evaluate x at 3, which would give us 30. Right? We'd have 30, got a minus 1, so that would give us 29 plus 5h. And then we could just let the calculator evaluate this expression for all these different values of h. So to get that done, you go to y equals, and we'll plug in 29 plus, now the variable here is an h, but the variable the calculator uses is an x. So we can just write this in as 29 plus 5x. So we get that into our y equals. Now the default setting in the calculator wouldn't need to change if you really want to make this process work nice and conveniently. So the default setting under the table set menu, which is in blue above where it says window, I want to access that. When it's second window, and we want to change this independent variable, which is now the x that we plugged in there, into y equals. We want to set that to ask. That way, rather than just automatically generating a list of values for the input, the calculator will prompt us to plug in the values we care about. So if we go to that second table set menu and select ask where it says independent variable, when I go to the table, which is second graph, right, in blue it has that table button there. Now we have a blank list and it's waiting for us to plug in whatever values of h, which we had defined x as far as the calculator is concerned. Right, we'll plug them all in here. So I can plug in 2, can plug in 1, 0.1, and 0.01, and that will complete the table for us. So that's the whole problem, and hopefully you find that helpful. Take care. Bye.